Welcome, everyone, to the second tutorial video of my passion project, Planarly. Planarly is an Affero GPL-licensed open-source research project to explore the potential of spreadsheets as a general-purpose two-dimensional programming environment. You don't need to be a programmer to use Planarly. In fact, Planarly takes a conventional spreadsheet user and gently introduces proper programming habits and more advanced topics in the familiar context of spreadsheets and cells. You may follow along with this demo by going to app.planarly.com. Chrome is strongly recommended. In the last episode, we looked at how to tabulate information in Planarly. In this episode, we'll look at making charts by interfacing with a charting library. Let's first re-enter the basic freelancer data. Anna, Bella, Crystal, and their amount. We can see that the columns can be referenced as hash name and hash amount. Recall that hash amount refers to the region amount to z amount. Now, let's make a pie chart showing the amount owed to each freelancer. Unlike conventional spreadsheets, Planarly exposes its users directly to the API interface of the underlying charting library. Currently, only ApexCharts is supported. It is a free, powerful, and well-maintained library, although you usually need to be a JavaScript programmer to make use of it. Let's see how Planarly can interface with it to draw pie charts. This chart looks exactly like what we need. To generate it, ApexCharts must be passed on this JSON configuration. JSON is a widely used simple data format capable of representing numbers, strings, and a few data structures. Namely, arrays, which are a sequence of elements, and maps, which are name-value pairs. Since Planarly's only data structure is the rectangular table, Planarly provides a toJSON function to translate them to JSON strings. Let's see some examples. A row of cells gets translated to an array, like this. And a table with keys enumerated vertically in the leftmost column gets translated to a map if the keys end with colons. A dash forces a single element to be seen as an array. More dashes form an array with more elements. These data structures can nest. Here is a map containing another map. The structures can be nested further. So let's make a table that can be turned into the required JSON. We can freely mix typed-in values and formula values. T is the transpose function. It swaps the rows and columns of its input. The rest of the specification fine-tunes the look of the chart and can be ignored for now. Let's call the top left corner chart data. Now, grow southeast chart data would start from the chart data cell and grow down and to the right until the bottom and right edges border only blanks. If we pass this region to the toJSON function, we'd now have the JSON string to pass to the ApexCharts library. Let's call this cell JSON. We have now prepared the required JSON. We proceed to create the actual chart. Let's rename the current sheet Data, and create a child node of the type ApexChart, named PyChart. In Planarly, the nodes form a tree like a typical directory structure. The sheet is the most common type of node, and only sheets can have children. We'll now configure the PyChart node to display the JSON we just prepared. We can set its options config to a formula, just like for a named cell. In this case, we wish to use the formula p.json. Recall that any name with a capitalized first letter is reserved in Planarly. A capital P denotes the parent node. Similarly, PP denotes the parent's parent, and PPP its parent, and so on. P.json is therefore the cell named JSON in my parent. We can see that the formula p.json has taken effect and assigned the correct value to the PyChart's options config. Great, and the ApexChart is now rendered. Going back to the datasheet, the reverse function of toJSON is unsurprisingly from JSON. We can use it to parse the string held in the cell JSON into a Planarly table. Let's call it parsed. We can use the square bracket operator to look up keys in the leftmost column of hash parsed. Or even nest them. And that is how to extract fields from a JSON string in Planarly. You've now seen how to work with JSON strings in Planarly, and how Planarly can act as the glue to control a programmer-oriented charting library. We look forward to interfacing more libraries and APIs from Planarly. You've now come to the end of the second tutorial video of Planarly. Check out our website, www.planarly.com, where you can find the documentation and try Planarly yourself. The software is being actively developed, so please be patient if you encounter any bugs or performance problems. The application runs entirely in your browser, and your data never leaves your computer. In the next video coming soon, we will talk about sheets as functions, the analog of user-defined functions in conventional programming. Follow me on Twitter, Dr. Planar. Stay tuned, and see you next time.